So another terms is called as a mineral admixture, which is given in clause 5.2 of IS 456. So in IS 456 2000, they are included these materials now. Before that earlier 1978, it was not there. Still people are using it, but now it has included in the code. So it's called pozzolanic activity or supplementary cementitious material. In short, we can call SCM. So we have fly ash, pulverized fuel ash, silica fume, rice husk ash, metakaolin, and ground granulated blast furnace slag. In short, we can call as a GGBS. This is also well-known material now in Mumbai. Microsilica you must have heard and fly ash you must have heard. These two are not very popular. Rice ash is very, very limited use, but still it has got very good properties in hydraulic properties on because it has got very good reactive silica in it. But it has to be burned at the particular that we'll discuss in detail. So these are the materials available to replace major part of cement can be replaced with this material without losing the quality of your concrete. Fly ash, silica fume, rice husk ash, metakaolin and GGBS. Now in further to that, there is a process fly ash is also available in the market. It's called ultra fine materials or microfine material that is also available. But his percentages are limited. Maybe go up to maximum 10%. And if you go here, fly ash can go up to 35%. This can go up to 10%. These are going 10 to 15%. And GGBS can go replace up to 70%. 70. I can replace OPC and GGBase up to 70%, and fly ash I can replace up to 35% as per the standard. But standard says you can go even higher percentage of fly ash also. It's called high volume fly ash. But then we have a proper data should be there with you, all including durability parameters. So we have classified fly ash. So these are all these are the material is less than 10 micron. Less than 10 micron. And here these materials are mostly less than 45 micron. So this is less, you can have classification by air classification. You can remove coarser material and get the proper fine materials, or you can grind the fly ash itself to get the fine material. Similarly, slag GGBS also we can grind further to desired level of fineness and particle size distribution and can be used in concrete to reach at very durable high performance concrete and limestone files. So using these three materials, OPC, mineral admixture and microfine materials, if you use, your paste will become very, very dense. Once your paste will become very, very dense, your strength levels are high, their durability levels are very, very high. You get very least permeability of that particular paste. So that is the ultimate aim for make a high performance concrete or durable concrete. This is you can see the physical shape of the materials. Now when you're looking at the cement, you take on your fingertips and you will find, though they are very fine particles, if you see under microscope, they look like this, like your aggregates, because your clinker has crushed. So once you get crushed, you get like this. So this is like a coarse aggregate or fine aggregate. Though they are very fine, maybe less than 20, 45 micron or 90 micron rather. Similarly, your GGBS is also similar in nature because that is also crushed to the particular fines. Metakaolin also similar but slightly rounded compared to this. But these two materials, which is coming, one is a fly ash, which is coming from your thermal power station, and it is a basically a flyaway material in the air. You collect with ESPs, electrostatic precipitator, and collect it. Their original shape is very, very round, like a ball bearing. So once you have OPC and you replace some amount of fly ash with OPC, suppose it's 100%, you require X water, and if you make 80 this and 20 this, you will find X minus water will require less for the same workability because the surface area of these particles are minimal and also the internal friction is also minimal. So you get very good cohesive mix when you are using these materials along with OPC. But major advantage of this fly ash shape you get, and this is also similar material, but these are very, very fine. So water demand is high. Here is not that fine because 45 micron to maybe 20 micron or 10 micron it is there. So you will not get much water demand, but if you use OPC, we will get more water demand and we get very cohesive mix. So this specification of this is given in the IS 3812, part 1 and part 2. One is you can use as a pozzolana to take the reaction of that and get the benefit of that particular material. So partly we can replace. And sometimes your sand is having lot of issues, suppose having very coarse sand. Then I can replace with this fly ash, coarser fly ash in nature, bottom ash or coarser fly ash or mound ash. These are the pond ash. These are the types where this is available and can be used as a part of admixture. So you get benefit of your material. Now, if you replace partly with your sand, sand is not reactive. This is in reactive in nature, but it will take very slow process because they are in coarse in nature. Coarser particles will take more time to react, but definitely there is a reaction. So long-term strength, maybe 1 year, 2 year will be very, very high. Especially now, whatever you get ready-mix mortars or dry plasters, people are using this as an admixture. Also partly pozzolana, partly as an admixture. So use maybe about 40, 50%, 60%. So 30, 35% goes as a pozzolana content and balance as a goes as a sand replacement because sand is not very good quality. This is you can see the flash like this. Sometimes is a slightly brown color is available. Suppose there is a iron available. Some of the like here in Mumbai, if you see, must have heard about Tata projects. This Tata power station is there in near Trombay. So whenever they fire, they use imported coal, and that coal has got a lot of your iron. So iron gives color to that, and also it has got a lot of lime. So that color is slightly in brownish in nature, and but normally you get this light gray or slightly dark gray, depend upon uh, quality of coal you use in thermal power station. You see under scanning electron microscope, you see the flash. See they are very spherical shape. That's what I discussed earlier. And this is able to give very cohesive mix in concrete. Very cohesive mix in the concrete. So you can see here. This is also SAM. These are the very good particles and very smooth surface. So when you do do some experiment with this, we'll find that this concrete is very, very good. So fly ash is basically a byproduct of coal-fired power generation plants. Reactivity of the fly ash depend upon their glass content, SiO2, and also there is a particles. Glass content in the range of 50 to 90%. That depends upon how it has burned. Because that glass also required to be a amorphous condition, not in crystalline. Crystalline glass will not react. So burning temperature is also very important. And fine particles will have higher reactivity. But fly ash is not a hydraulic binder. When presence of water and calcium oxide, which is coming from your concrete and cement, it is reacting. Itself, fly ash will not have any hydraulic properties because you don't have any CaO. The class C fly ash having CaO, they may set or they may having reactivity as it is. But generally we get around 90% fly ash, we get class F, where it doesn't react. So uniformity requirements are there because they are collecting in various fields. So collection point has to be decided properly, and residue on 45 micron we can check regular basis. Because in the field, when you go to thermal power station, you have got 4 to 5 dust collection centers. One is very, very coarse material. Generally, we use from field number 2 to field number 3, which is useful for your concrete. Field number 4 and 5 is also very good, but very limited amount is available. They are very, very fine. But that how you control at that site, you can do wet sieving and find out what is the residue on your 45 micron. So whenever your fly ash comes, initially you have to test in third-party testing, do all the analysis, chemical and physical. And for the quality control at site, because site is very difficult to do the fineness or chemical analysis, but the particular thermal power station will not change the coal. Once there is no change in the coal, the chemical analysis also will not change. So what we have to ensure is always I should have a particular size of material. So I can check with 45 micron and see my consistency of that. Now this range is given, maximum up to 34% is allowed in concrete. Coarser than that is not allowed. But in 34 also is not good for high grade concrete. When you want to go high grade concrete, we have to put our own limited, where when you are making a concrete, when you are making lean concrete, you can go up to 34%, no issue. But you are going to high strength concrete, your high performance concrete or self compacting concrete, you limit it to 15%. So retention on 45 micron limited to only 15% is for good concrete and important concrete. PCC and other thing, even you can use even up to 34%, because IS says up to 34%. If you see the British standard, they says up to 12% only. To make a good concrete, because they should have efficient ESPs at the thermal power station, then only will get good fly ash. Now replacement level is around 15 to 35% given in the IS code. So whenever you are saying any cement content, that also includes this fly ash. Suppose there is a 300 kg minimum specified or 400 kg minimum specified cement content in IS 456 for the particular exposure condition. So that 400 also contains this fly ash also, including mineral admixture. That If you see the note in that, it is given. When you discuss about mixed design, we'll discuss in detail. Then we can go with high volume fly ash. Also, people have done huge work on this high volume fly ash because huge amount of fly ash was available. Nowadays, we are able to consume it. But if you go back maybe 10, 15 years, there's an issue how to manage the fly ash. There's no proper storage of the fly ash at the thermal power. Huge amount of fly ash is generated. Then we started using in concrete, and also we have started using Portland pozzolana cement. All cement factory they have tie up with that, and they make the Portland pozzolana cement. But if you have the economics, you can site, you can have proper mix design with as per your requirement. You can play with this requirement 15 to 35% and get very good economical best concrete. This is discussed. Now, what are the benefits in your fresh concrete? As I said, your water demand is typically lower by 5 to 10%, depending on the your particle size distribution of particular fly ash. So definitely there is a benefit. For the same workability, I need less water. So same workable, I may get more strength because water cement ratio lower, you will get more strength. Since they are reacting very slowly, maybe after 7 days or 3 days, your heat of hydration is lower, which is best for your large pore, like very huge foundations, where I can use this in replacement level maybe up to 35% and reduce heat of your total concrete, which will have benefit to the reduce your possibility of thermal cracking. So we are using partly as a replacement for reducing the heat of hydration. If you use 100%, we'll get huge heat. Reduce around 35%, the heat will be reduced. Higher workability, same water content, the same 0.1 and 0.3. We can have very good control over segregation bleeding because these are very, very fine materials. Gives excellent cohesive mix. Those who are working on fly ash, they will understand when you are using fly ash, you get very good cohesive mix. It's very easy to pump. Pumping is very difficult. Very good finishes. Very low permeability. Lot of benefits are there. And then you can use as a partly as a sand replacement also. Suppose you have a sand having lacking in fines, then definitely we can use this as a sand replacement partly to get very good concrete. You cannot consider it as a pozzolana material. You can have the inert material, but definitely it will have reactive also. That is additional benefit you get. Then longer setting time, this can be decided, but don't make a direct statement when you are using fly ash, it will have more setting time. Today we have got very good admixtures available. Then we can have a proper what you call regulated or designed setting time of concrete, depending upon your project requirements. So that, but definitely this sentence is, or this point is basically we are comparing 100% OPC and OPC plus fly ash. So definitely OPC per fly ash will have more setting time or hardening process is slightly more. In a 1 day or 3 days strength will be slightly lower. 7 days also may be slightly lower, but 28 days may be same. But if you say 90 days or 180 days or after 1 year, the OPC fly ash concrete will have more strength, very high strength compared to 100, because OPC will hydrate around 90-95% at up to 28 days. But here it will hydrate only about 80% or 75%. So latter edge strength is very, very high in this. So what we are advising is whenever you are doing any foundation of the building, where on the foundation the load may come after 1 year or 2 years. So you better go with the fly ash concrete and optimize your economical mix and take the advantage of that latter strength. So by the time 6 months, 8 months, or 1 year, your concrete will achieve your design level of strength. There's no point in insisting 28 days strength at 28 days for foundations. Slab, I can understand we have to de-shutter or something. But foundation, why? All your foundation can go design for 90 days or 60 days. Possible? So, this is possible. So, your now new code has introduced for high-rise building in I think 2016 or 2000. I don't remember the number is 16700. 16700 for high. There they are now included. Your foundation can be designed up to 90 days strength, not for 20 days. Earlier IS 456 always says that we should have a design all the concrete, whatever was read in all literature. Our requirement is only at 28 days. But this new IS code, taking the benefit of all these your mineral admixtures, you must design even at 90 days, or you can have a because some of the foundation, if you see, they're designed for 6 months or even 1 year. But when you are designing such thing, your project, your concrete mix design should start well early in advance, and you should have data for it. Otherwise, structural engineer will not accept your argument, because strength development in all depend upon their particle size distribution, replacement level, and chemical composition of your fly ash. And for that only you need to have a trials. So if you have a mixed design done earlier to starting of the project, maybe 6 months or 1 year earlier, that data can be accepted. Now such data is available with ready mix concrete, because there's a basically they produce the concrete. So they have data with them. This particular mix has after 1 year, what will happen? Theoretically, we can calculate maybe 5%, 10%, what is increase is there. But realistic picture will come depending on all these parameters as I discussed, the chemistry of the fly ash, particle size of the distribution of the fly ash, and compatibility with the particular source of cement. That gives you proper use of this fly ash and get benefit of that particular fly ash in concrete. Finishability is excellent. You get very good finish. You must have heard about this Bandra Worli ceiling. They have used around 50% replacement of fly ash for their foundations, because these are all marine structures. High volume fly ash concrete they are used. And pumpability, because when you push the concrete through the pump, there are a lot of friction reduced because of your sand and aggregates, and even for your cement, because cement is also like an aggregate only, have a huge friction. So if you use fly ash, you'll find pumping is very easy. If you note down the pumping pressure, it is reduced, and you can pump very easily up to 1 kilometer also, not any issue. Today we are going by high-rise building, maybe 300, 400 meter height. It's very easy to pump using fly ash. Now, now this last slide. Benefits of hardened concrete: high strength at latter edge, as I discussed earlier. Drying seekage marginally higher, but since water demand is less, is equal to OPC. Because water demand is less, you take the advantage of that. Less permeable compared to OPC. That is a good advantage to have a impermeable concrete. Abrasion resistance equal to OPC or slightly better than OPC because it has got again a glass. Glass content is there. Sulfate resistance is improved. Reduction in expansion caused by alkali silica reaction. So amount of alkalis remain in 100% OPC. You can replace part amount of fly ash. So you are reducing in the alkalis which is not available for reactive aggregate. So expansion with alkali silica can be reduced. And as I discussed, is also low heat of hydration benefit to your members, because now if you see most of the your columns of your high rise building come in the definition of mass concrete. So any member is minimum size of that member is more than 1 meter comes in the definition of your mass concrete, and mass concrete will have this issue of thermal cracking. So there we can improve using this material. Also subsequently we'll discuss other material also during our lecture. Whatever we have specified, like microsilica is there, metakaolin is there, isos ash is there, and GGBS there. We'll also spend more time on GGBS because that is also a good material and is available in Mumbai and elsewhere also, and used in concrete very effectively to get very good marine concrete and resistant to the sulfates and chlorides both. Here only sulfate is given and some amount of, due to the permeability, we get resistant to the chlorides. But seawater we have both chloride and sulfate. That we'll discuss, I think, in next lecture.